In this video, we're going to have the first introduction to the concept of a vector. We will not be going into too much detail in this video, but we will have further videos in the future where we talk more about vectors. So first things first, the idea is a vector. This is something with magnitude and direction. So for example, you might say, I need to travel 30 miles due east. So I'm giving you the direction due east. I'm telling you an amount, 30 miles, and those things together make it a vector. If I just said I need to travel 30 miles and didn't include the direction, that is called a scalar. Just a magnitude, no direction. But as I said, we're focusing on vectors right now. So the idea is we can describe a vector geometrically as an arrow points a certain direction and it's going to have a certain length to it. So let's say this one is length 10, and we might describe this direction here as 30 degrees or whatever angle it might be. And I might have another vector that is only 8 long and has a direction of, I don't know, 50 degrees here. So vectors are going to be described as arrows for now. They will also be described in other ways in future sections. And the few things that we're going to look at right now is if we have a vector, we would like to know its components. Now, what do I mean by components? Is if you were to take these pictures and you were to complete them into right triangles, you are going to have the horizontal side and the vertical side. This horizontal side is going to be called the horizontal component, and the vertical side is the vertical component. These can also be called the x component and the y component. So in general, if you had a vector v, then this length down here in the horizontal direction, we might call that Vx, and this vertical component, the length there, we call Vy. I want to point out something that we're using notation here is that if we use the letter and we put this little arrow on top of it, that means we're indicating it's a vector quantity, so it has magnitude and direction. If we do not use the arrow on top of it, we're just talking about the length or the magnitude. Now sometimes if we want to be really sure that we're indicating its length and not the vector itself, we will put bars around it. So the vector v is in fact this arrow right here. If I wanted just to talk about the length of this arrow, I could put the absolute value signs around it, and that just means the magnitude or the length of this vector slash length. So there's different notation here. Sometimes you'll see people put the absolute value around the Vx or the Vy, but it's not really necessary because there's no arrow on them. So we shouldn't be confused that it's not a vector or in fact it's just a length. But again, sometimes you may see them put bars on it. So I would say these are equal here, but kind of unnecessary to have the bars. Now, there's a whole lot of things that you can do with vectors, especially in physics. If you're talking about traveling and you're talking about vectors, well, that would be velocity, whereas the magnitude would be the speed. So if I'm traveling at 50 miles an hour, that's a scalar. Scalars would be the speed. If I say I'm traveling 50 miles an hour north, then that would be magnitude and direction. That would be the vector. We call that velocity. Similarly, there's a vector which we call acceleration that's talking about how we're changing in our velocity. And there's one that's talking about distance, but in terms of direction as well, kind of like that 30 miles due east, that's called displacement. And it turns out that the vast majority of physics is all based on vectors. I mean, certainly scalars are part of it, but vectors is the kind of basis for almost all of physics. So you're going to have to get very familiar with these ideas as you go further. Now again, there are going to be some better ways to look at vectors than just looking at it graphically. It might be a real pain to draw out every single vector you ever wanted to work with, especially if you wanted it to be accurate. So as I said, there's more algebraic ways to deal with vectors. This is just introducing the graphics and some interpretation of what's going on here.